Good afternoon, everyone. Welcome to our first online session, first online session of the semester. Um, I hope you guys can hear me. It's just perfect, beautiful. Yeah. So for online sessions, if you have any questions or contributions that you want to bring on board, please feel free to stop me straight away. You don't need to wait for me to finish the session or what. You can just stop me as I'll be talking or explaining. Because I'm going to share my screen, and while sharing my screen, I won't be able to see the chat. So, or you can also write your question in the chat, and at the end of the session, I will have a look at the chat and see and respond to your question. So this afternoon we're going to carry on from where we left last time. So let me quickly share my screen. For some kind housekeeping rules. So please make sure that your mics are off at all times. Unless you want to say something, you can unmute yourself, then you can let me know that you want to say something, right? So obviously you will unmute yourself and stop me there, and then you can say whatever you want to say. Um, right, so my screen should be visible on your side. So I think this is the management services group. So we did quite a lot on Monday. So I think we spoke about the naive approach. I believe we spoke about the moving averages. If I'm wrong, please, you can just unmute yourself and let me know. We went through this exercise, I believe so. I don't know if we did the exponential smoothing. For those who were here on Tuesday, who attended the class on Tuesday, did you cover here the moving average? I mean, here the weighted moving average. Because from what I know, I think we're supposed to start from here. Please confirm that so that you can begin. No, guys, I told you when I'm asking you a question, do not use the emoji because it won't be showing on my side while I'll be sharing the screen. I say you must talk. You must unmute yourself and talk. Otherwise, I won't be able to see. All right, so I think you guys are confirming that. Perfect. So the other technique that is used in terms of the other technique that you can use in terms of conducting the forecasting analysis is what you call the exponential smoothing. It's a weighted moving average forecasting technique in which data points are weighted by an exponential function. So obviously in this we have an idea, or the aim is to ensure that the company is exponentially growing in terms of producing the product that the company is producing. So we talk in terms of growth, sorry, because we are exponentially producing. So that means that the production for this year should be less than the production for next year, and so on. So we are talking about the growth in terms of production. So when it comes to the exponential smoothing, this is the formula that we are going to use. It says here the new forecast, so the forecast of the period that we are calculating is equal to the last period's forecast plus, between bracket, plus alpha. So alpha here is a constant between 0 and 1. At your level, in all the assessment or the scenarios that you are going to have at the first year level, you will be provided with the value of alpha. So the value of alpha will be always provided, even in the test. So your job is just to do the calculations. Please don't generate your own value or your own values of alpha, because there could be 2, 3, 4, depending on the scenario. So you just need to make sure that you abide by the one provided in the test, or the ones provided in the test. Now, it's a between bracket last period's actual demand minus last period's forecast. So now let's look at a simplified version of this formula. So here is FT. So FT is the new forecast, right? Equals to the forecast of the previous period and plus alpha. Between brackets, you have the actual value of the previous period minus the forecast of the previous period. So in this case, you also need to know the difference between the actual values and the forecasted values, so that you don't confuse the two. Now let's look at this example just to apply the formula. It says here in January, a car dealer predicted February demand for 142 VW Polo. Actual February demand was 150 VW Polo. Using a smoothing constant chosen by management of alpha equals to 0.20, the dealer wants to forecast March demand using the exponential smoothing model. So what you need to understand here is that they are at the beginning of January, they projected the demand for the upcoming month. In this case is February. They said, okay, or they did their calculations, and that gave them a value of 142 cars that they were going to sell at the end of February, which is a prediction. Now, coming the end of February, they managed to sell 153. This is the factual or the actual value. This is what the company actually managed to sell. instead of the predicted 142. So this one here is the actual value, and this one here is the forecasted value or the predicted value. Now coming to the formula says that FT here in our case is going to be March. So this is the forecast for March. So F March equals to the forecast. So FT minus 1 is the forecast of the previous month. So the previous month here is February because we are predicting March. And what is the forecast of March? The forecast of March, February. Here's the forecast of February, 142. That is the projected value. Plus alpha. Alpha is provided 0.2. Yeah, put it here. And between brackets, you have the actual of the previous period. So the amount of cars that they actually managed to sell in February, because we are talking about T minus 1. So the previous period. So the actual, what they managed to sell in February is 153. That is the number. Minus the forecast. So the forecast here is still 142. So these two values here must be similar, right? FT minus 1, and you still also have FT minus 1. So that's what you have here. The forecast 142 plus the 0.2 for the value of alpha. And here you have the actual 153 minus the forecast 142, and then you do your calculations. So what I usually do is that when I'm using your calculator to avoid making mistakes, I usually start with this section here, or this portion of the equation. So I start with the section between brackets. After I will multiply that answer by the value of alpha, and then lastly you will add the forecasting. I think that will give you the final answer, which is 144.2. So in our case here, as I have already explained before, you can leave it as 144.2 because we are not presenting this result to people. But if you are presenting to people, you may just round it down instead of up. Okay, so 144 cars, because you can't have a car that is half, right? So that's gonna be 144. You can play around with that if you want, but the safe way is just to leave it like that, especially for our online test. Are we all on the same page, guys? Please unmute yourself and let me know if you are all on the same page.
Yes.
Beautiful,
Yes.
beautiful stuff.
Yes.
Beautiful. Thank you. So let's proceed. Now, this is another example related to the exponential smoothing technique. So if you look at this example here, guys, let's assume that we don't have this section here. Let me just, if I can write something, let me take the pen. So let's assume that we don't have this section. No. Okay, let me do this. Yeah, so let's assume that we don't have this section here. So what we need to do here you have two values of alpha. Alpha equals to 10, alpha equals to 0.10, alpha equals to 0.5 or 0.50. So with these two values of alpha, we are going to do the forecasting analysis for each of the values of alpha. This is just to test the accuracy of our calculations or our analysis. And at the end, we are going to choose which value of alpha gives us better result, you know. So that will be the idea behind having two values of alpha, to check or to measure or to determine the value of alpha that provide us with values that are more accurate. Right. So in this case here, these are what you call the actual values. And here, obviously, this is our period. So in order for you to start a forecasting analysis, you need to have what you call the initial value. So the initial forecasted value. If you don't have this initial forecasted value, you won't be able to kickstart with your analysis when it comes to the exponential smoothing technique. So how do you go about doing that? This value is usually provided or openly provided. Or it can also be provided using what you call the naive approach. So the naive approach, so that means that you have to use a naive approach in order to get the initial value, and then you can kickstart with your calculations. There is a question where we are going to do, even if you don't do it today, I'm going to post it on Moodle where you are asked to extract the initial value using the naive approach. So you guys will try to do it, even if you don't understand, it's not a problem. That question, just try that question the way you can. And then when we will meet or when we will discuss that question, I believe you'll be able to understand what it's really going on. Now, let's come back to this one. So in this case here, we have the initial value, which is provided here, 175. This is the forecast value here. Now, the formula says, let's just calculate this one so that you guys can see, because it's going to be the same thing for other calculations. Just to do the first one for all of us to be on the same page. Let's say discard. All right, let me do this. Let me close this page. Guys, please make sure that your mics are off unless you want to say something that is going to benefit everyone. All right, so we say that, so basically here, we are going to calculate quarter one because we already have the forecast for quarter two. We already have the forecast for quarter one. So let's say forecast of quarter two. So we're going to have the forecast that we call FT. Let me try to zoom it in a bit. FT is equals to the forecast of the previous period, FT minus 1, plus the value of alpha. Between brackets, you have the actual of the previous forecast minus the forecast of the previous period. All right. So this is the formula. Now, in this case here, FT obviously is quarter two. Now, FT minus 1. This is the forecast of quarter one. And this is also is the actual of quarter one. But if you look at the table, we have all the information that we need for quarter one. So we have here the actual 180, the forecast 175. So the forecast 175 plus the value of alpha. I think alpha is 0.10. Between brackets, it's gonna be the actual minus the forecast. So the actual in our case here is 180 minus 175. And then you do your calculations. I believe you're going to have 175.5. So this is our forecast by doing these calculations. So looking at what we have here, it gives us the forecast of week 2. Quarter 2 is 175.5, what we obtained there as well. Now, you're also going to do the same thing for quarter 3 up to quarter 9. So quarter 3 here, you're now going to make use of these two values here. So always make sure that you use the data of the most recent period. Never use the data of the period that you are calculating. For instance, you are calculating quarter 3. You cannot use 159. No, you must always make use of the data of the previous period. Now, here's what you also need to be mindful of, is that let us assume that you, by doing this calculation, you make a mistake here and you probably get 150 or 140. You will see that that mistake, you're going to carry on with that mistake until the end. So obviously your final result will be wrong. So this kind of questions, I would suggest that if you have time after doing your calculations, please go back and double check your calculations if everything is in order or if everything was conducted accurately. Because if you make a mistake here, all this will be wrong. So usually even when I'm marking this kind of questions, I usually focus on the first value, the few first values, and usually the last value. Right. So just be careful with that. So what you have done here is also the same thing that you are going to do with alpha equals to 0.5. It's the same thing. I'm sure some of you might ask me a question, sir, what about the actual of quarter 9? Factually speaking, you cannot calculate the actual because the actual, that is exactly the number of cars that the company here are we talking about cars here? I don't know exactly. They say actual tonnage unloaded. So that is the actual number of tonnage that the company managed to unload. So usually we don't calculate it. If I ask you to calculate the actual, meaning that I just wanted to test your capabilities or abilities to handle the kind of to handle equations, right? Just for calculation purposes, but not, a business from a business perspective to get a number and resonate from there, because you don't calculate the actual number or the actual values. So just just need to understand that, because I got a question there in the other group there. All right, so once you get this is now going to lead us to what we called measuring the error of the analysis. So in order for you to check the accuracy of your calculations, you have to measure the forecast error. And there are three ways to conduct the forecast error or to check the accuracy of their analysis. You can either use what you call the mean absolute deviation, which is the MED, or you can use the mean squared error, MSE, or you'll use the mean absolute percent error, MAPE. So in our case here, we are going to use, or at your level, we'll be just talking about a MAD and MCE. So MSE, sorry. So these two. This one you guys will see it in your second here. But for now, we'll just limit ourselves to these two. Now, they say the forecast error is equal to actual demand minus the forecast value or forecasted values. So here, what is the actual? What is the forecast? You can see in this case here. Here, this is the actual. This one is the forecast. So the error that you are talking about here is that difference, because if they predicted that probably they were going to unload 175 ton of whatever that they are producing, and at the end of quarter one, they managed to unload 180. So there is a gap there. They didn't unload exactly the same number as they predicted. So there is a gap there. So that's what you call that margin error is what you call the error or the deviation. So looking at this formula here, you can see it says the actual minus the forecast. That is the deviation or the error. And this error, we are going to use it in order to determine the mean absolute deviation and the mean squared error. So in order for you to calculate the mean absolute deviation, you must make use of this formula. But we are going to break down this formula, right? Because when you see this signs here, it's just telling you that whatever calculations that you are going to do within these signs, the numbers must always be positive. So the sum of the actual minus the forecast divided by the number of period. Now, let's look at the example again. Same example. But for now, let's focus on alpha equals to 10. 0.10, sorry, 0.10. So first thing first, we have to calculate the deviation or the absolute error or the absolute deviation. Now, in this case here, it says that in the formula, actual minus the forecast. So this is the actual. So 180 minus 175, that gives us 5. That is that difference there, that's error. Here you have 168 minus 175.50. So once you do that, normally it was supposed to give us a negative number. However, we must be dealing here with positive number. Even if it gives you a negative number, but you must write that number as positive. Or what you can do if you are not quite comfortable going directly, you can probably create another column here whereby you can write 168 minus 175.5. That will give you negative 7.5. Can have that column where you write exactly what you are obtaining by subtracting, right, the actual from the forecast value. But in this case here, it's straightforward. The negative number that you'll get, you just turn it into positive because you only want the positive value. Please never mix the positive and the negative, because if you sum up everything here, you'll get 82.45. However, if there are negative numbers here, you will never get the same total. So the sum of the deviations here, or the sum of the errors here, will give you 82.45. Now, once you have this sum, now you divide this sum by the number of period. So how many period do we have here from 1 to 8? That is a total of 8 period. So you're going to have 82.45 divided by 8, and that would give you 10.31. This is our mean absolute deviation with a value of alpha equals to 0.10. Perfect. So we are done with alpha. Let's move on to alpha equals to 0.5. So we are doing this because what we have done here with alpha equals to 10 is also the same thing that you are going to do with alpha equals to 0.5. Right? You already have the forecast value here. So again, you take the actual minus the forecast, and then that will give you the deviations. So you sum up everything, you're going to get 98.62. Again, you're going to take this divided by the number of period, which is 8. And that will give you an absolute deviation, the mean absolute deviation of 12.33. Now, you have these two values here. Which value of alpha do you think provides results, or the MAD that is more accurate, or provide results that are more accurate, or results that are better in terms of accuracy?
It's 12.33.
You said 12.33, right? That's what you said, right? Oh, okay. Okay. Who else disagree? I mean, who can say something here again? In case you disagree with what your classmate just said there. He said that the 12.33, so that is alpha equals to 0.5, provide better results compared to the other one. That's what it's saying. Any other thoughts around this? How about you guys? Any other thought? Yes, please let's talk. If you guys don't want to talk, I'll just stop right here and then you guys go and find out yourself.
They are both accurate.
They're both accurate.
Yes.
Okay. Okay, let's take the very last contribution before I say something. So who else can say something here? Your first classmate said that. Yes.
The mean absolute deviation for alpha with 0.10, the 10.31, I think it's accurate.
Okay. All right. Thank you for your contribution. So the idea here when you are calculating the mean absolute deviation, because basically you are checking the margin of error. if I came back to this example here, yeah, this one here, and I said they predicted by doing the calculations that they will, at the end of February, they would sell 142 cars. And actually at the end of February, they managed to sell 153. Let us assume that their prediction here, or the predicted value here, is 153. So meaning that their prediction here is 153. And exactly at the end of February, they managed to sell 153, so the same number. So in that case, if you take 153 minus 150, it will give 0. So that means that their prediction the prediction was accurate, because the same number that they predicted is the same number the same number of cars that they managed to sell. That is kind of a perfect prediction, very accurate. So 153 minus 153 is 0. So the idea here is that when you are calculating the mean absolute deviation, it's a kind of error that you are calculating, measuring the error. So you will take the error that is the closest to 0, or the least number, if you can put it that way. So the number that is close to 0, that is the number that you are going to check, and that will be the one that will be providing you with results that are more accurate compared to alpha equals to 0.5. So the value of alpha equals to 0.1 is preferable in this case because it provides an MAD that is close to 0 or closer to 0. Right. So that is how you should justify and come up with the value of alpha that is more accurate. Because usually what you do is what? The question can come in the way or in the form of saying, okay, you do all these calculations, yeah, right? And then the follow-up question will come. They say, which value of alpha do you think, or based on your calculation, not do you think, based on your calculation, which value of alpha is more accurate? You choose the value of alpha that is more accurate, and then the other question will come and says, predict year 9, for instance, or quarter 9, sorry, quarter 9 with the value of alpha that you have chosen, that you have said that is more accurate. So you can see that question is linked to your previous choice based on your calculations. So if you don't choose the appropriate value of alpha, you won't be able to get that question right. All right. So yeah, that's how you approach this kind of questions. So you just need to know your story, and they are not difficult questions to tackle. All right, ladies and gentlemen, you're going to get the last one is sorry, the MSE. MSE here is also roughly, I'm gonna just explain quickly. They say sum of the forecast errors squared divided by n. So here is still the same thing. The actual minus the forecast, so 180 minus 175, that gives us 5, squared, that gives us 25. That is what you will be doing. 168 minus this is going to give us a negative number squared, right? It's going to give us 56. Obviously, the negative part will disappear. Any number squared will just give you a positive number, whether it's a negative or not, right? So once you do that, again, we're going to sum up everything, right? Calculate the total, and that total divided by 8, the number of period, it's going to give you the MSE. And you also do the same thing with alpha equals to 0.5. and then you compare the two. Now, here's the reason why I usually don't bother too much with MSE, because the conclusion that you are going to make using the MAD will also be the same conclusion that you are going to get by using MSE. So sometimes there is no need to calculate both of them. But if you are asked the question in the test just for testing your understanding, but not like coming up with different conclusions. Yeah. Trench projection. This is for you guys who are going to do the second, doing second here. Ladies and gentlemen, I think we have reached the end of this of our session. I will just quickly have a quick look at the chat box if we do have some questions there that need to be clarified before we.
Hello, sir.
Yes.
I would like to ask, how can we get access to the recording?
How can we get access to?
This class recording.
Oh, do you want the recording? But you attended the session, right? Do you still need the
Yes, sir.
recording?
Yes, I think I need it.
Okay. Okay, I will upload it tomorrow, I think. Tomorrow I will upload it.
Sir,
Okay,
you
sir.
said you
Thank
are
you.
going to update us or Rangwalaneng. When are we writing? You didn't.
Oh,
Okay.
yeah, you guys going to write on the 20th of March from 10 to 12. Your venues are, let me show you quickly.
Wait. Wait.
Let me show you quickly, but I will post this online anyway. Uh, okay, this is DFC, oh, APB. And you see, so everything was booked. And you see this, I think you write that side. I don't know if you guys are familiar with that side. It's outside of the campus by Buxton. Say Buxton. So these are the venues. I think there are three. There are three venues: Buxton, Room 101, Buxton, Room 102, and Buxton, Room 301. But don't worry, I will post this on Moodle so that you guys can consult at any given time.
Please post the slides too.
The slide.
Which chapters?
Yes,
The slide. Yeah, I'll give you guys the slide if I don't forget. By tomorrow, I'm sure you should be having the slide. No worry.
okay, thank you, sir.
Yes. Somebody wanted to say something? Please feel free if you want to ask a question.
Which chapters are we writing based on?
I think it's 1 and 4. Double checking the learning guide.
1 and 4.
I
or
think
1
so.
to 4.
With 1
No,
and
Yes.
401.
guys, that's what I'm.
Yes, chapter
You
1 and
guys.
4.
Yes, that's what exactly. That's what I'm saying. 1 and 4. I didn't say from. I'm just saying 1 and 4. 1 and 4. Okay, let's read what is in the chat box. Sir, could you please repeat explaining the mean alpha, the mean absolute deviation? Must we still explain this or what? Please unmute yourself and tell us. Open the mic to us. He says because he will not be able to see the chat. Okay. Sir, I'm lost when it comes to deciding which alpha is most accurate one. Repeat that, okay? Sir, the alpha value is always below 1. Guys, those who asked this thing, do you still want me to explain or? But it seems like our time is even over. Supposed to end here at 25. So, for those who still want me to explain this, no worries. Next week, I believe we're going to have enough time. Please, you can just see me after the session on Tuesday, and then I can quickly explain those questions or those section. No worries. Or you can also come and consult if you want. So guys, thank you for attending. Our time is already over, so I'll see you next week. Let me stop sharing. But remember to attend the tutorial. I'm
Sir,
out. Yes.
sir,
Yes, I'm almost.
did you display the code for attendance register or you are taking it through the meeting?
This. Okay, for this session here, I'm gonna take it through the meeting. I mean through Teams.
Okay, sir.
All right. Okay, cool guys. I'll see you when I see you. I'm out.
Ah.
So